Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture for May 27th of 2025 is titled Zeta and Rho Ophiuchi with the Milky Way. So what do we see here? Well, I'm going to turn the image sideways a little bit for you and apologize that the writing does not turn with it, but I think it's a little easier to see this way. What we are looking at is a region near the constellation of Ophiuchus, and this is actually one of the constellations near the ecliptic or the path of the sun. So it is one of the constellations that the sun, moon, and planets will pass through. Typically, those are the 12 zodiacal constellations, but Ophiuchus is the 13th constellation. Once constellations were defined specifically back in the 1920s by the International Astronomical Union, and then the sun actually spends a good amount of time passing through this area. Now, we see down toward the bottom, and that would be the lower right here, we see part of our Milky Way galaxy, and we see the bright star clouds, the brighter regions. Those are made up of many millions of stars that happen to be located in that direction, which are all so distant and so close together that we just see the cloud of light there. Now, the darker regions are dark dust areas within our Milky Way galaxy, and those are not an absence of material, but there's actually more material there, and in fact more larger particles, which we call dust, that block out the light from behind. So those, if it were not for the dust, those regions would be just as bright as the neighboring brighter regions. Now, as we look up toward the top of the image as we're looking at it here, we see to the left the Zeta Ophiuchi nebula. Now, this would be an example of an emission nebula. An emission nebula occurs when hydrogen gas is energized by the ultraviolet light from a hot star. So the bright blue star at the center there gives off most of its energy in the ultraviolet. That ultraviolet light is capable of ionizing hydrogen gas, stripping the electrons off of it. And then as those electrons recombine with the hydrogen, they will give off distinctive energies. And one energy that they give off that's in the visible portion of the spectrum is in the red. So hydrogen gas, when energized, often looks very red, as we see here. Now, down below this, we see the clouds of the Rho Ophiuchi, and there's a number of different ones here. Some of them are red and are energized hydrogen gas, but we notice some blue there as well. The blue is a little bit different. That is caused by reflection. It is actually scattering of the light of the stars by dust grains. So when there's a lot of dust, it blocks out the light, and we see the darker brown areas that are the dark nebulae. But when there's just a little bit of dust around the star, it's really good at scattering light, and preferentially scattering the blue light, the shorter wavelengths. Much as our own atmosphere scatters the blue light from our sun, making our sky blue, well, here we get to see the blue light being scattered from the star off of those dust grains. So even in that area, we can see some darker dusty areas where the dust is denser, but the less dense areas around the star then give us that distinctive blue glow that is a reflection nebula. So that was our picture of the day for May 27th of 2025. It was titled Zeta and Rho Ophiuchi with Milky Way. We'll be back again tomorrow for the next picture, previewed to be Powerful Space Jet. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.